Hello students, welcome to today's class on linear equations in one variable. Linear equations in one variable. You can see clearly. We are discussing about equations, in that specifically about linear equations, and again specifically about one variable linear equations. So my name is Avinash and I'm graduate from IIT Kharagpur. Let's start today's class. So first of all, let us see what is a linear equation, what is a variable, what is a linear equation, one variable, and then we'll go and solve some applications based on that. The very first thing, we will see where this concept is actually applicable. I'll give you a small statement. There are two friends, Ravi and Rohit. Okay, so there are two friends who are playing with numbers. They took one random number. Okay, they're playing, they multiplied, they added, they subtracted, and they're giving a question to the other person to find the number. One small example, Ravi tells Rohit. So Ravi is speaking to Rohit and he is giving one puzzle, one question. What is that? I think of a number. Okay, so who is I? Ravi, because Ravi is telling Rohit. Okay, I means Ravi. I think of a number. So Ravi is thinking of a number. If I double it, that means double means we are multiplying with 2. We are multiplying with 2. And take away means we are subtracting. Taking away, for example, you have 10 chocolates. I'm taking 5 from that. I'm taking 5 chocolates away. That means we are subtracting from 10. I'm taking 5, so you're left only with 5. If I take 2, you're left with 8. So we are subtracting. Taking away means subtracting. Okay. So double means multiplied by 2. Taking away means subtracting. And finally you will get a 50. Finally you will get a 50, right? Can you tell the number that I thought of? If this is a situation that taking a number, multiplying with 2, subtracting -5, and we got finally 50. So we need to find what is that number, how to find that. So that is where linear equations concepts will be applicable. So first of all, let us try to represent the same given data using mathematical terms, mathematical expressions. Okay, I think of a number, so let us take that number as x. Let us take that number as x. If I double it, we are multiplying with 2. Double means we are multiplying with 2. 2 into x is 2x. Simple algebra. 2 into the number x is 2x. We are assuming the number as x. And take 5 away. We are taking out 5. Okay. So 2x minus 5. Take away 5. We get 50. Taking away, we get 50. What is that particular number? How to solve the linear equation? We'll try to see later. But here, whatever the equation we wrote is a linear equation. The equation 2x minus 5 is equal to 50 is a linear equation. The first thing you need to understand here, what is equation? I'm saying linear equation. What is equation first of all? What do you mean by equation? You know already algebraic expressions, correct? In the lower classes, you learned what is algebraic expression. This is an algebraic expression, 2x minus 5. This one, equated, that means using equal to symbol. If we equate this to the other number, this forms an equation. This forms an equation. And when you are saying about equation, we may have linear equation or some other equation. So again, we need to distinguish every equation, whether it is a linear or not, whether it is having one variable or two variables or more than two variables. Here you can see in this entire equation we have only one variable. What is that? That variable is x. We have only one variable, which is x. Right? So how can I say that it is a linear equation? Let's move ahead. let's move ahead and let us try to understand which type of equations are called as linear equations. Okay, so the first one we are going to discuss is an algebraic equation is, so we are discussing about equation. Okay, equality, just now told you there should be an equal to symbol, equality. An algebraic equation is equality of algebraic expressions. You know what is algebraic expression? Just now we discussed. Okay, so 2x minus 5, this is an algebraic expression having variable x, constant 5. Okay, so 2 is also constant, that is being multiplied to x, right? So this is an expression which when equated equal to symbol to 0 or to 50 or to 55, whatever the number it is, depending on the situation. So this is considered as an equation. Okay, I'll give you one more. 2x square minus 5x plus 6 equal to 0. Even this is an equation. Whenever you have equal to, it is enough to say that it is an equation. But in our present topic, we need to understand what is linear equation. When we're discussing about equation, we need to understand what is a linear equation. Okay, so first of all, let us try to understand what is a linear equation. What is a linear equation? You can see here, equation which can be written in the form of ax plus b equal to 0. Ax plus b, ax, so okay, that x should be there. You cannot, in place of x you can have y, you can have z, you can have a, b, c, whatever it is, that is not a matter. Okay, but we should have one variable only. We should have only one variable, and you may ask me, sir, what about a and b? A and b are not variables, they are fixed numbers, they are constants. Okay, something like the number which we just discussed, 2x minus 5, 2 is fixed, you cannot change that. 5 is fixed, you cannot change that. But in place of x, it is a variable, you can keep any value. You can keep 1, 2, 3, minus 1, minus 2, whatever values you can. Correct? That is the reason that is called variable. And there is one more condition where a and b are real numbers. You may get a doubt, what do you mean by real number? In the last class, in the previous classes, we discussed what are natural numbers. You learned what are whole numbers, what are integers. And going forward, we also learned what are rational numbers. But at this point of time, if you still don't know what is rational number, no problem. Okay, so natural, whole numbers, and then integers, then rational numbers, then irrational numbers, all these clubbed together are called real numbers. So that a and b can be natural, can be whole, can be integers, can be rational or irrational, whatever it is, but the only condition is a should not be equal to 0. The value of a should not be equal to 0. Why? Can anyone tell me why a should not be equal to 0? If a becomes 0, so this entire ax term becomes 0, you're left only with the b equal to 0, which is not a linear equation. It is an equation, I understand that. We have an equality, it is an equation, but we don't have a variable ax terms. That is the reason it is no more a linear equation. It is no more a linear equation. Okay, degree of linear equation is 1. What do you mean by degree? If you observe 2x minus 5, I'll give you one more, 2x cube minus 5x square equal to 0, equal to 0. What is the only difference here? Numbers are same, equal to 0 is same, equal to 0 is same. Okay, equations are correct. But I say this is a linear equation, this is not a linear equation. So now you need to observe that. You need to observe why the first one is considered to be linear equation, why not the second one? X power 1, x power 1, that 1 is what it says a linear equation. Always for a linear equation, the degree should be equal to 1. Here, the degree is 3. What is degree? The power. That power is 3, so it is no longer a linear equation. I'll give you one more. 2x plus 3y is equal to 5z. Is it a linear equation? X power 1, y power 1, z power 1, all powers are equal to 1. There is no square term, x square, x cube, x power 4 or y square or z square, nothing. Only x power 1 or y power 1 or z power 1, always it is 1. So that 1 is enough to say that it is a linear equation. The degree of a linear equation is equal to 1. That should always be standard number. It should be 1 only. Only then we can say that it is a linear equation. Right, let's move ahead. Consider the following equations. Okay, a simple application. Let us try to understand more about linear equation. Just not told you about degree, correct? The power of x. Which of the following are linear equations? Which of the following are linear equations? Observe the first one. You have 2x minus 7 equal to 35. 2x minus 7 equal to 35. So you can see that x power 1, nothing is there, no problem. Here also no x terms are there. The only x term we are having, and that is x power 1, it is enough to say that it is a linear equation. The next one you having x power 1, y power 1, it is enough. You don't have any x squared term, so it is a linear equation. The next one, you have 4x power 1 here, again the same 2x power 1 here, no problem. Only the degree matters, only that power matters to say whether it is a linear or not. But the last option, careful, we have x power 2 or x square. It is a second power, second degree, which is not a linear equation. X square, which is not a linear equation. Understand? Okay, so first, second, third are linear equations. The fourth option is not a linear equation, right? So let's move ahead. Okay, solve the linear equation. How to solve equations? We just discussed what are linear equations. Is this a linear equation? Yes, why? Because x power 1, it is x power 1, 2x power 1 minus 3 is equal to 10. So now the point is how to find the value of x which satisfies this equation, which is called solution of the equation, which is called solution, the value of x. The value of x which satisfies this equation is called a solution. Okay, so 2x minus 3 is equal to 10. 2x minus 3 is equal to 10. So 2x is equal to 10. This minus 3 will come here. Okay, now once again understand. Whatever we have to the left side of equality, we say LHS. The left side of equality, we say LHS, which stands for left hand side. Which stands for left hand side. And the other part, the right side part, is called RHS. RHS, which is called right hand side. Which is called right hand side. So now the point is, whenever you want to find the value of x in the equations, you should have only x at one side, all the remaining values on the other side. Okay, now let us try to understand term by term, step by step, how to solve this equation. Carefully observe, we have minus 3, which we don't want because we just need x. First we'll eliminate this minus 3 and then we'll come and eliminate this number 2. To eliminate this minus 3, we will add plus 3 on both sides. We'll add plus 3 on both sides. So tell me what you'll get. So if you add plus 3 on both sides, so it is simply 2x minus 3 and plus 3 gets cancelled, both become 0, is equal to 10 plus 3 will give you 13. 10 plus 3 will give you 13. So now how to avoid this 2, how to eliminate this 2? It is being multiplied. 2 into x multiplied. So you need to divide so that we can eliminate 2. Carefully see here. There is a minus 3 negative number. We added the same positive number. We have a number in multiplication. We will divide with the same number. Okay. So dividing with 2. Divide 2 on both sides. So you will get 2x by 2 is equal to 13 by 2. So any number gets cancelled, 2 and 2. So 2 and 2 gets cancelled, you will get x is equal to 13 by 2. You will get x is equal to 13 by 2. So that is how you calculate these values. Calculate the value of x. The value of x which we get finally is called solution of the equation. Solve means finding the value of x or finding the solution of the equation. Finding the value of x or finding the solution of the equation, 2x minus 3 is equal to 10. Okay, carefully see here, we have added, we have divided, but let us try to see the same thing in a short method. Okay, instead of writing all these always, we'll try to find some simple procedure to solve these type of equations. Okay, so 2x minus 3 is equal to 10. Whenever you have one number and you want to transfer to the other side, if it is in addition, that will become subtraction. If it is in subtraction, that will go for addition. It is multiplied, then it will be divided. If it is divided here, that will be multiplied. That means, see here, 2x minus 3 is equal to 10. 2x minus 3 is equal to 10. So the point here is, instead of writing adding plus 3 on both sides, we say we transfer that minus 3 to the other side. We transfer this minus 3 to the other side. So 2x is equal to 10. Minus 3, I told you, if it is a minus, that will become positive. If it is positive, that will become negative. Plus with minus or minus with plus. So it is already minus 3. Will be transferred to the other side, becomes a plus 3. So 2x is equal to 10 plus 3 is 13. 2x is equal to 10 plus 3 is 13. So the next point is divide with 2. Divide with 2. Okay, because 2 is being multiplied. 2 is being multiplied. So we'll divide that one to eliminate. Okay, so x is equal to 13. This 2 will come down. This 2 which is multiplied will come down and will divide on the other side. A plus number will be transferred to become negative. Negative number transferred become positive. Multiplication transferred becomes division. Division becomes multiplication. Here it is multiplied, so it is being divided. So x equal to 13 by 2 is the solution of the given equation. X equal to 13 by 2 is the solution of the given equation. Clear? Straightforward, very simple process. I'll give you one more question, then you will understand more better on how to solve linear equations. It's very simple and interesting. Okay, solve the linear equation 3y plus 39 equal to 8. The very first step, you have plus 39 transferred to the other side becomes minus 39. Instead of saying always this side and that side, we use standard notations LHS and RHS. Plus 39 on LHS left hand side will be transferred, will become minus 39 on RHS. Okay, so 3y is equal to 8 plus 39 will become minus 39. So 3y is equal to 8 minus 39. Again, integers, you have already learned that. But if you're still confused, just subtract 39 and 8. 39 minus 8, how much is that? 31. 39 minus 8 will give you 31. So that is 31. But now, you should be very careful with the sign. For the highest number out of 8 and 39, whatever the sign is, the same sign will come. Out of 8 and 39, what is the largest number? 39. What is the sign for 39? What is the sign? Is it positive or negative? It is a negative. So the same negative will come here, minus 31. So now this 3 will come here and will become divided. So y is equal to minus 31 by 3. Y is equal to minus 31 by 3. Clear? This is how you can try to find the value of y or x or t, a, b, whatever the variable it is. You just need to eliminate one by one till the last step where you get the variable value exactly. Right? So one more question and then we'll move forward for the next topic. Solve the linear equation 8x plus 5 by 2 is equal to 13. 5 by 2. It's okay. Don't panic. Don't need to worry anything. Just send that 5 by 2. Other side becomes minus 5 by 2. So 8x is equal to 13. This plus 5 by 2 will become minus 5 by 2. 8x equal to 13 minus 5 by 2. So 8x is equal to, now the point here is you need to take LCM. Okay, so how to take LCM? We already learned in lower classes, but once again I'll tell you in the next coming problems wherever it is required. But now between 1 and 2, as 2 is a prime number, okay, as 2 is a prime number, it is enough to say that the LCM will be the product of the numbers. Whenever you have one prime number, it is enough to say that if you try to multiply those two, that will be the LCM. Okay, so this becomes 2. So 2 divided by 1, 2 divided by 1 is 2. 2 into 13, 2 into 13 is 26. That is how you take LCM. Minus 2 divided by 2 is 1, 1 into 5 is 5. So what is 8x? 8x equal to 26 minus 5, which is 21 by 2. 26 minus 5, which is 21 by 2. Okay, so send this 8 here. X is equal to 21 by 2. This 8 being multiplied, now it will come to denominator and divided. So 21 by 16. The value of x is 21 by 16. Clear? Very simple. I'll give you one more question so that you can try on yourself, which I'm not going to cover now. Okay, x plus 4 by 3 is equal to 3 1 by 2. 4 by 3, okay, but what is that 3 1 by 2? Mixed fraction. Remember what is mixed fraction? What is mixed fraction? Okay, if you have a b by c, if you have a b by c, you need to multiply these two and then add b. You need to multiply AC and then add plus B. AC plus B by C. That is how you bring mixed fraction to proper or improper fractions. Okay. So that is a 3 1 by 2. 3 1 by 2. So 3 to the 6. 6 plus 1. 3 to the 6. 6 plus 1 is 7. 7 by 2. 7 by 2. Okay. So finally we'll get x plus 4 by 3 is equal to 7 by 2. So you try to solve this one. 7 by 2 minus 4 by 3, and you need to take the proper LCM to get the value of x. What are the value of x you get that should satisfy this equation? And that is called the solution of the equation. Solve means find the solution of x. Find the value of x which satisfies the given equation. Understand? So I hope you understood about linear equations, right? We have one more question. You can take that as an assignment and we'll cover that in the next class. Sum of two numbers is 29. One number exceed another by 5. Find the number. Find the numbers. Okay. I'm not going to help you, but using the information whatever we have discussed till now, so please try to do this one. Okay. So right. So that's all for today's class. We discussed what is a linear equation, how to identify whether given equation is linear or not, and then we also discussed solving few linear equations. So coming ahead in the next class, we are going to learn more applications on linear equations, right? Thank you so much. Stay tuned to get the next lecture. Thank you.
Yeah. Hello everyone. So now we'll be discussing about the types of forces. So my name is Shashan Reddy. I'm a graduate from IIT Dhanbad. So let's go into the class. Okay. So here, first of all, we'll try to classify them into two types. Okay. We'll try to divide forces into two main types. And the basic difference between those two main types will be given here. So what difference do you notice between the forces? Here and here. Look at them. Look at both the cases. Look at this left case first. Here, which type of force is acting? Yeah. Here, the force acting would be magnetic force. Notice the main thing that you can notice, is the balls are getting attracted even when they are not touching each other. Even when they are not touching each other. So, if force acts even when there is no contact. I can write force acts even when there is no contact. Even when there is no contact. Clear? Yes. Here you can see there is a person who is trying to lift a weightlifting. But here, to lift that weight, the person has to touch it. Contact is required. Contact is compulsory. Contact is compulsory. Yes or no? So there are two different cases we can see here when force will act. In this case, the weightlifting case, touch or contact is compulsory. The person has to touch it, touch the object, touch the weight. But here the magnets, they get attracted even when they are not touching each other. That is, the force is acting even when there is no contact. So we have two different types of forces. What are they? One is called as contact force. The other is called as non-contact forces. Now very simple definitions for both. For contact force, those are the forces for which contact is required. Contact is compulsory. Example, muscular force. That weightlifting was an example of muscular force. Friction. There are many such examples. We'll go into them. What is contact force? Forces for which contact is compulsory. Contact is required. What about non-contact forces? Those are the forces that act even when there is no contact, even when two objects are not touching each other. Example, magnetic force, gravitational force, electrostatic force. Magnetic force, we have a good idea. Gravitational force also, we have a basic understanding. What is electrostatic? We will learn about that. Okay, so let's go into each and every force, individual forces, one by one. Okay, so we'll start with contact forces. Contact forces, you have frictional force, we have muscular force, we have tension, we have spring force, we have normal reaction. Let's go into each and every one of them. Let's start with friction. So here, imagine this, or you can try doing it now itself, right now itself. You would have a table. On the table, just place a book and push the book slightly. You can say this is a book, this is a table. Okay, and push it slightly and see what happens. Okay, I'll just explain that to you. But something like this, look at the book. The book is pushed. What happens? The book will finally stop. See that? If you push the book moves and stops. The book moves and stops. So here, the motion was towards right. Now, why did the book stop? Who is stopping the book? Which force is stopping the book? In the effects of force, force decreases the speed, or force can stop a moving object. That is, if a body is stopping, a force should be acting on it. And which force is acting? That force we call it as friction. It is the opposite force. Motion is towards right. Friction will try to stop it by applying a force in the opposite direction. And who will exert friction? Who will apply friction? The table. Table applies friction. Okay. So what is friction? It is a force which opposes motion. Which opposes the motion. When you go into the chapter friction, then you learn about that in much more detail. We'll now go into The basics only. And in fact, all types of surfaces like solid, liquid and air offer the force of friction. Right, and friction acts in the opposite direction of motion. That you can clearly understand here. The second point, all types of surfaces like solid, liquid and air. It's a very basic, a very important point. Now, when does air offer friction? I'll give an example. Now, let's say you're cycling. Now, when you're cycling, let's say you're cycling bit fast. Can you feel that air will be pushing you back? You're cycling forward and the air will be pushing you back. We can notice that. All of you would have noticed it. Yes or no? So that air in that case is trying to oppose your motion. Is trying to decrease your speed. Yes or no? So which force is air applying? Air is applying friction. Air is applying friction. So that is one example of friction by air. Similarly, liquids, water can also apply friction. Understood? Okay. In simple terms, friction is the force which opposes motion. And how will it act? If motion is towards right, friction is towards left. If motion is towards left, friction will be towards right. So friction is in the opposite direction of motion. Basic. Clear? Okay. So that's friction. Now we have muscular force. Now we know what muscular force is. The force that is applied through the action of muscles. For everyday life, whatever we lift, right? For anything we have to lift, we have to apply force. And how do we do that? We apply that using muscles. Muscular force. Right, so muscular force is the force applied using parts of the body like arms or legs. It is a force that results due to action of muscles. Yes. And most important point is that it is a contact force. Right, if I want to lift this pen, I have to touch it. Without touching it, I cannot lift it. There is no magic. Yes or no? So I have to touch it. So it is a contact force, and since contact is compulsory between us and the object. That's muscular force. Clear? And you can clearly see here, when you lift your hand, what happened? Your biceps, they are contracting. Right? You can clearly see the biceps. Okay? So they contract or expand, depending on the case, depending on the action. But that's how muscles apply force. That's how we apply force. Clear? So muscles exert force by the action of contraction and expansion of muscles. A bit of biology, bit of bio. Right? Okay. Now we learned about muscular force. Now we learn about something called as tension. Not this tension, not the headache tension. Tension is force. Yes, it is. Force by what? It is force by a rope, by a thread, by a string. Okay? Tension is a force exerted by a string or a rope. Now imagine this. When you play tug of war, okay, you have a rope and you pull it. Yes or no? In a tug of war, there are two teams and the two teams pull the rope. Right? So the rope will apply force. So rope will apply force. That force is called as what? Tension. And where else can we see it? In a pulley. So in a well, from a well, if you have to draw water, we pull what? We pull using a rope. Some examples. Clear? So it is what? It is a self-adjusting force. Its value depends on case to case. Its value can increase or decrease. And most importantly, using a string, you can only pull an object. Imagine this. You are pulling water. You are drawing water from a well. You pull using a string. You don't push it. Push is not possible. You drop the bucket and pull the rope up. Yes or no? Yes. So using a string, you can only pull. That is the reason why. So a string can only pull an object such that the tension force is along the string and away from the object. So here if this is the object, it is, let's say it is tied to a string. Okay. Now how will the string apply force? The string can only pull the box. It can only pull it, it cannot push. It can only pull. That's the specialty of tension, it can only pull. Clear? I'll just write that down here. Tension can only pull. Clear? Okay, that's wonderful. Now we have spring force also, which is force applied by the spring. Okay. Look at this. Now when you compress a spring, when you stretch a spring, does the spring apply force? Yes, it does. Yes or no? When you compress a spring or you stretch a spring, in both the cases. Yes? The force applied by the spring is called nothing but spring force. Now how and all I'll explain. Look at this. A spring exerts a force towards the equilibrium or mean position when the spring is compressed or elongated. What does the equilibrium or mean position mean? Let me explain. Here, look at the different cases. We have different cases here. Look at the first case. In the first case is what we mean by equilibrium position, where the spring is not compressed, where the spring is not elongated. There is no compression, no elongation. So the spring is in its natural length. So here there is no force. So whenever there is no spring force, that is what? That is equilibrium position. Let's say this dotted line shows us what? This is the position of the block where we call equilibrium position. Spring is in natural length. It is not compressed. It is not elongated. So no spring force. But in the second case, the spring is compressed. Block has moved towards the fixed wall. The spring is compressed. Now when you compress the spring, how will the force be? Yeah, how will the force be? When you compress the spring will try to push away. Yes or no? So here the spring force, see it is towards the right. Towards right will mean towards the equilibrium position. This is the equilibrium position. So this arrow is towards equilibrium position. Right? Now when again if I take the third case, which is extension, when the spring is extended, when the spring is elongated, then see what happens. Then also the spring will try to pull it inside. So the spring force again is towards the equilibrium position. Understood? So that's what we mean when I say a spring exerts a force towards the equilibrium or the mean position when the spring is compressed or elongated. When the spring is compressed or elongated. Is that clear? Yes? Okay, wonderful. Now, that was spring force. Now we'll go into normal reaction. What is normal reaction? Look at these books. These books are placed on a table. Now, on these books, what are the forces acting? You can take one book, for example. Imagine that there is one book placed on a table. Everyone knows that's a gravitational force. Okay. So if gravitational force by Earth is acting, it should go down. It is not going down. That means there is someone stopping the books from going down. Who? The table. How? The table applies an upward force. And that force by the table is called as normal reaction or normal force. Okay. So here normal reaction is a force that acts perpendicular to surface. This is table surface and force is upwards. The normal reaction, the normal force is perpendicular to the surface of the table. That acts perpendicular to the surface. Simple. Is that clear? Understood? So those are some examples of what? Of contact forces. We started from friction, muscular force, tension, spring force, and normal reaction or normal force. Now, we'll go into non-contact forces, or also called as field forces. These are the forces that act even when two objects are not touching each other. That is, when two objects are like this, they are like far away. They are like far away. Okay, so what are they? Simple example: gravitational, electrostatic, magnetic. Okay, I'll go into the explanation, don't worry. See, when we talk about gravitational force, let's say this is the ground. And let's say this is any object. So, and there is an object in air, and is that object touching the ground? No. But if I drop the object here, just let go of the object, what happens? That object falls towards the earth because of gravitational force. That object will fall towards the earth because of gravitational force. So gravitational force is acting on the object. Now again, are they touching each other? Is the object touching the ground? Ground is earth. So is the object touching the earth? No. No contact, but force is acting. So which force is that? Non-contact force. So gravitational force is a non-contact force. And look at this. There's an interesting video here. Okay. So there is that. Who is that? That's Newton. Newton sitting under a tree, and an apple falls on him, and he starts thinking that why is the apple only falling down? And that's how the story of gravity starts. Okay. But yeah, that's a simple story. We'll come back to the points. Objects fall towards the earth because the earth pulls the objects towards itself. Every object. Okay, earth will pull every object towards itself. That is, there is a force on us, on the screen, on the pen, on the remote, on everything that you can see towards the earth. Clear? And gravitational force, always attractive. Always. Earth always attracts things. Earth does not say no. Earth always says yes, yes, everyone come towards the earth. Clear? And it acts on all objects, even on air. In fact, gravitational force even acts on air. Interesting, right? Okay. Then we will go into magnetic force. What is magnetic force? For that, obviously look at these videos. Magnetic force is force between two magnets, or force exerted or applied by a magnet, in simple terms, right? So here look at this interesting video. Just a minute, I'll play it. Look at this. That will be interesting. What's happening? Magnet is getting repelled. So that's the case of what? Magnets repelling each other. Right, that's the case of magnet repelling each other. But if I go with the other case, this case here, see what's happening. What's happening here? They attract. They are getting attracted, yes or no? So that is the example of attractive magnetic force. Magnetic or where magnetic force is attractive. So you know where it happens. Like poles repel each other, unlike poles attract each other. Simple. So magnetic force is obviously one thing that you could have noticed in the videos is the magnets attracted or repelled each other even when they are not touching each other, even when they were not touching each other, right? So magnetic force, as you can clearly see, it acts between two magnets or between a magnet and a magnetic material like iron. Yes or no? And contact is not necessary. Yes. And it can be attractive as well as repulsive. We just watched the video. It can be attractive as well as repulsive. Magnetic force. Very simple. Clear? Now we'll go into electrostatic force. Look at this video here. Have any time done this? Have any time played in this way? Just take a comb, rub it on your hair, place it on paper bits. the paper bits get stuck, right? They fly up and get stuck or get attracted to the comb. Yes, many of us would have played it. The question is, which type of force is acting? Is it gravitational? No. Is it magnetic? No, plastic is not a magnet. So there should be some other force. And where or how did that force start? By rubbing. By rubbing the comb on your hair, yes or no? Yes. The same thing, another similar case is here. It's a rod. A rod would have been rubbed with a cloth, and aluminum foil bits are flying towards the rod. Similar examples, right? So that is the case when we say when objects are rubbed against each other. Imagine the comb rubbing on the hair. What happens is we say that they get charged. What happens? They get charged. And the force acting between the charged objects, that we give it a special name called as electrostatic force. Electrostatic force. And contact is not necessary. The paper bits fly up without contact. It's not necessary for electrostatic force to act. Okay, simple points understood. There is one point which you have to remember as of now, so please remember. That is, it can be both attractive and repulsive, like magnetic force. Just remember it as of now. Okay, so that's it, everyone. We learned about what? Contact and non-contact forces, and different type of forces or different examples